Okay, we're recording. Very good. Very challenging times for everyone right now. I'm just going to have a tutorial video. Seeing that I grew up in New South Wales, I've chosen to take on some old New South Wales HSC exam papers. So in this first video, I'm just going to do the first 10 multiple choice questions. I haven't used these with any of my students, but we'll see how we go. Question number 1. What is the value of pi squared divided by 6? Correct to 3 significant figures. This is quite an easy question. Let's just grab our calculators out. Pi squared divided by 6. We want 3 significant figures. Really, that means we want 3 digits. So let's not round to 3 decimal places. We want 3 digits total. So the first 3 digits I see are 1.64, and the very next digit is a 4. So the preceding digit does not round up. So our answer should be 1.64. Question 1 is A. Question 1, A. Question number 2. Which graph best represents y equals x minus 1 all squared? Well, first we'll notice that it's a quadratic. It's a positive quadratic, so each one of these satisfy that condition. They're all facing up, and we can also recognize that this equation has 2 solutions of 2 roots. Both of them are x equals 1. X equals 1. So that is going to be the point where the parabola just kisses the x-axis, and the only one of the answers which x equals 1 is a solution to y equals 0 is B. So question 2, quite simple as well. 2 is B. Question 3. What is the solution to the equation log base 2 x minus 1 equals 8? That's a very interesting question. Off the top of my head, I'm leaning very strongly towards D. We need to understand how logarithms work. So log base 2 x minus 1 equals 8. Log base 2 x minus 1 equals 8. Really, what's it saying? Is it saying 2 to the power of 8 equals x minus 1? So if we add 1 to both sides, we've just found out x. So we'll type into our calculators 2 to the power of 8 plus 1. That gives, plus 1. That should give us 257. 257, and that is D. So question 3, we are looking at D. Question 3, D. Let's have a look at question 4. Which expression is equal to the integral of e to the power of 2x dx? Okay, now off the top of my head, I'm leaning towards C. C, and let us have a look at how we can achieve that. I'm going to use u substitution to achieve this. So, okay, I want the integral of e to the 2x dx. Now, I have really 2 functions here. I'm looking at my exponential function and exponent. My exponent is 2x, so it's a rather complex situation. Let's substitute 2x for the variable u. The variable u. U equals 2x. Now, I want to get my integral in terms of u, so I'm going to find the derivative of u. The u equals 2 dx. And if that was a little bit too tricky, you may have seen it written like this: du dx equals 2, and you can get away with multiplying both sides by dx, although in some cases this is not a valid operation, but we're going to let us get away with it for now. So I have du equals 2 dx. I would like to have du in my initial expression, so I need to multiply by 2 on the inside of my integral. I'm going to multiply by a half on the outside of my integral. So effectively, I haven't changed the integral at all. I've just multiplied by 2 times a half, which is just 1. So I'm going to go 1 half on the outside, and a 2 in here. That allows me to do the substitution. 1 half. Oh, what is happening here? 1 half integral of e to the u du. Now, the integral of e to the u is simply e to the u, and don't forget the half at the front here, and the constant term, and now we can just do the substitution. We know that u is 2 to the x, so the solution should be 1 half e to the power of 2x plus c. Let's have a look. 1 half e to the power of 2x plus c. So question 4 is indeed c. Go up. 4 is c. And I'm just going to erase page 2, start a new page. Let's continue. Which equation represents the line perpendicular? Okay, immediately we should recognize that perpendicular, if you take a gradient of perpendicular lines and multiply them together, we will always get -1. So that's an important property to recognize in this question. Which equation represents the line perpendicular to 2x minus 3y equals 8, passing through the point 2, 0? Okay, this is not one that I can do off the top of my head. So we're going to take the initial equation, I'm going to rearrange it into the general form so I can easily read off the gradient. And with that gradient, I'm going to use not with that gradient. I'm going to use that gradient to obtain the perpendicular gradient. And that perpendicular gradient, I'm going to make it go through this point 2, 0, and find the equation that satisfies that situation, that scenario, those properties. And that will be very much easier to see with the diagram. So 2x minus 3y equals 8. Let's start off with this equation. 2x minus 3y equals 8. I really don't want to get that wrong, so let's make sure minus 3y equals 8. Very good. Let's get that to standard form. I'm going to put the 3y on the right hand side. I'm going to take the 8 to the left hand side. So please allow me to do this quickly. We have 2x minus 8 equals 3y. I'm going to get rid of this 3, so I'm left with y all by itself. So I'm going to go and allow me to rearrange this into the standard form. Y equals 2 on 3, x minus 8 on 3. Very good. Change color. There we go. Let's recognize that this here is the gradient of my first line. We could call that, if we want, m1. And what I would like to do is find m2, knowing, as I said before, m1 times m2 equals -1. So let's just put that in. 2 on 3 times m2 equals -1. I'll multiply both sides by 3, divide both sides by 2. So m2 equals -3 on 2. So I have the gradient of my perpendicular line now. So I have the gradient of my perpendicular line, but I have a graph where we're looking at -3 on 2. That's going to look something like this. Even shallower than that, but I don't know if it's going to be there. There's an infinite number of lines that I can draw with this particular gradient, m2. I need only one line. That one line, oops, that was not what I meant to do. That one line that passes through 2, 0. So 2 here, 0. Let's say roughly there, if this is the value, x equals 2. So I know m2 is equal to -3 on 2. All I'm going to do is I'm going to say y equals mx plus b. I'm going to substitute in my m. I'm going to substitute in my y. And I'm going to substitute in my x. I'll find the b, and that's all I need to know the equation of this line. So y is the point 2, 0. X here, y here. Y is 0 equals -3 on 2. That's my gradient. X is 2 on 2 plus b. If I add, so this term here is -3. If I add 3 to both sides, I'm going to have b equals 3. So my equation should be y equals -3 on 2x plus 3. I think they had it in a different form, so I'm going to times everything by 2. 2y equals negative 3x plus 6. So we have 2y plus 3x equals 6. 2y plus 3x equals 6. 2y plus 3x equals 6. 5 must be b. Happens to everyone. 5 equals b. Okay, next question. Question 6. Which expression is a factorization of 8x cubed plus 27? Now this is an interesting question. I have not done one of these for some time. The first thing that jumps out at me is we have cubes in each of these terms. 2 cubed is 8. 3 cubed is 27. So effectively I have 2x cubed plus 3 cubed. So how can we expand this? 2x cubed plus 3 cubed. We will close this. Yep. Bracket 2x cubed plus 3 cubed. It has been quite some time since I've done a question like this. There must be a trick. Let's explore what that trick is. Okay, let's take a guess. Something like this, 2x plus 3. And we're going to have here, perhaps, 2x minus 3 squared. Let's explore. So on this, I have 4x squared minus 6x plus 9. 2x plus 3, distribute the 2x. So I have 8x cubed minus 12x squared plus 18x. And then I have plus 12x squared. This is looking promising. Minus 18x plus 27. 12x squared, 18x, negative 18x. That leaves me with 8x cubed and 27. How did I guess that? Honestly, I apologize. I'm not sure how I guessed that. 2x plus 3, in brackets, 2x minus 3 squared. I think the answer has been stated in this particular form. If you were a student, we would go through and explore this, but I'm going to continue with the exam right now. 2x plus 3, 4x squared minus 6x plus 9. 4x squared minus 6x plus 9. That looks like a D. Question 6. Question 6 is D. Okay, question 7. How many solutions? Oh, I love questions like this. How many solutions of the equation sine x minus 1, 10x plus 2 equals 0 lie between 0 and 2 pi? Oh my goodness. This is a juicy question. We're going to have to talk about sine. We're going to have to talk about tan. And we're between 0 and 2 pi. We're going to have sine x. We're going to have tan x. So we're not complicating things with sine 2x or sine 3x or anything like that. Okay, new page. Yep, thank you. Let's have a look at sine. Sine looks like this. If we're talking in radians, this is pi here. This is 2 pi. What does tan look like? Tan looks like something like this. And that repeats the periodic functions. Okay, this is 90 degrees. So that must be pi on 2. Just in there. This particular spot here is pi. This is pi plus pi on 2. So we're talking 3 pi on 2. And we have one more there. That would make 3 pi on 2. That doesn't look right. I need to make my eraser a little smaller. All right, how do I do this? Yeah, there we go. 3 pi on 2, not 3 pi on 4. There's the rest of my tan. Looks pretty ugly. Sorry about that. Make sure I hit the asymptote. There's another asymptote. So this point here is 2 pi. Very good. We've got the graphs that we need. Let's look back at question. Sine x minus 1. Sine x minus 1 bracket tan x. What was that? Minus 2? Plus 2. Plus 2 equals 0. So this is only 0 when this bracket equals 0 or this bracket equals 0. So this bracket equals 0 when sine x is 1. And sine x equals 1. And this bracket is 0 when tan x equals negative 2. So let's have a look. This is 1. Down here is minus 1. So between 0 and 2 pi, there's only one spot right here that sine x is indeed 1. And that looks like it is pi on 2. So that looks like 90 degrees. Pi on 2. Pi on 2 appears to be one solution. Tan equals negative 2. Let us have a squeeze. Negative 2, let's say, might be down here. Negative 2 between 2 pi and pi. Let's have one solution here and one solution here. Let's just ask what they're actually asking us here. How many solutions of the equation? Okay, lie between 0 and 2 pi. So one of the solutions is pi on 2. But is it really? Is it really? I think we should talk very quickly about domain and ranges. Since if we inspect the tan domain, so if we're talking about domain, we're talking about all allowable x's. Let's have a look at this tan domain. We can basically use any x we want, so long as it's not pi on 2, 3 pi on 2, or any integer, any n, pi on 2. Is that right? No, any 2n. Ooh. N pi plus pi on 2. That sounds about right. So we can't be pi on 2, we can't be 3 pi on 2, we can't be 5 pi on 2, because we don't have allowable x's for that. That means we're talking about infinities. So although we have pi on 2 a solution from the sine perspective, it's not allowed in the tan domain. So for that reason, I'm going to go with, we only have two solutions. A solution right here and a solution right here. Okay, we're going to go 7, B. How did I move there? 7, B. I made a mistake there. 8. Which expression is a term of the geometric series? These are good questions as well. They can get quite tricky. Nice and challenging. Which expression is a term of the geometric series? 3x minus 6x squared plus 12x cubed minus that. New page. Thank you. 3x minus 6x squared. 3x minus 6x squared plus, was that 12? 12x cubed? Yes, it was. Minus Well, let us have a look. We can say, and it started with 3x. I'm sorry to skip so many times. So we're going to say 3x. How do geometric series progress again? Times 2x. Oh, this is a negative. Oops, I have to do that. Times negative 2x, and we're going to put this in. Let me put times there. Please allow me to use a dot for times. Negative 2x to the power of n minus 1. So let's just check that works. N equals 1, and we have a 0 up here. Anything to the power of 0 is 1, so the first term should be 3x. Let's say n equals 2, so we have 2 minus 1 is 1. 3x times negative 2x gives us negative 6x squared. That looks good. Say n equals 3, so we have a square up here. A negative number squared will be positive, so we have 4x squared times 3x, that d is 12x cubed. So it looks like we have the right formula here. Now, we're looking for when the exponent is either 10 or when the exponent is 11. And we're going to look at the coefficient here to see which coefficients line up with the digit 3072, whether it's positive or negative. So we're looking for the exponent of 10 or the exponent of 11. So I'm going to try n equals 11 or n equals 12. Hang on a second, that's not correct. I want to try n equals, yes, it is correct. N equals 11, n equals 12. I can write my 12 correctly. N minus 1, if n is 12, we have 11 up here. 11 times 1 is, no, what n minus 1? I want 10 and I want 11. 10, n equals 11. I'm sorry if I'm frustrating people. Maybe quite frustrating. So that makes 9, that makes 10, and 11. Very good. So let's try. We have 3x negative 2x to the power of 9. We also have 3x negative 2x to the power of 10. Let us see what we have in the calculator here. So 2 to the power of 9 will equal times 3. Over here, I have 1536. This is going to be x to the power of 10, and this is a negative. Over here, I have 2 to the power of 10 times 3. I have 3072 x to the power of 11, and in this case, this is a positive. Let's have a look. I think this is the answer we're looking for. 3072 x to the power of 11. To the power of 11, that is C8. So question 1, sorry, question 8. So let's have a look. The graph shows the displacement x of a particle moving along a straight line as a function of time t. Which statement describes the motion of the particle at point P? I'm going to read that again. The graph shows the displacement x, okay, of a particle moving along a straight line as a function of t. The graph shows the displacement x of a particle moving along a straight line as a function of t. Okay, I understand. The particle is moving, let's say the particle is moving up or down. As t changes. So it's moving up. It's stationary, it goes down. Which statement describes the motion of the particle at point P? So we're talking about acceleration, obviously. At this stage, we can, considering that concavity reflects acceleration, we can say that over this period here, acceleration is negative until, this is because it's concavity down, until we reach an inflection point somewhere around here, and now the concavity changes, becomes positive. So acceleration is positive in the domain that A exists in. So I'm going to say, acceleration is positive. It's either A or C. Although acceleration is positive, the particle is moving down. And so since it's moving down, the velocity is in fact negative. So we're looking for negative velocity, positive acceleration. The velocity is negative, acceleration is positive, so we're going to go with 9A. 9A. And let's have a look. 3 runners compete in a race. The probabilities that 3 runners finish the race in under 10 seconds are a quarter, a sixth, and 2 and 5 respectively. What is the probability that at least one of the 3 runners will finish the race in under 10 seconds? Excellent. In questions like this, question 10, I like to use this little rhyme. At least one means not none. Now that's the rhyme. How do we apply it? Not none. Not none. So we can find the probability that none of the runners will finish the race in under 10 seconds. So that none of the runners will finish the race. And if we want to find the probability that none of the runners will finish the race, we just simply subtract that from 1. 1 being 100% of the cases, or all of the cases. So we will find the probability that runner 1 does not finish in under 10, 2 does not finish in under 10, and 3 does not finish in under 10. And that looks like it's going to be 3 on 4, 5 on 6, and 3 on 5 respectively. So what do we have? 3 on 4, we have 5 on 6, and we have 3 on 5. Let's just check those. 3 on 4, 5 on 6, 3 on 5. Yep. We're going to multiply these together because they are our probabilities. Let's see if we can simplify. So this is a 1, this is a 2. I've got a 5 here and a 5 here. So effectively what we have on the top is 3. We have 3, and on the bottom we have 8. 3 over 8. 3 over 8 chance that none of them will finish within 10 seconds, but I want not none of them to finish. So I'm going to just go 1 minus 3 over 8. And that will give me 5 over 8 as a probability. 5 over 8 is D. Question 10. What's D? D. Question 10. D. Okay, let's see. So I'm going to go, my answers will be over here. First one, A, B, D, C, B. A, B, D, C, B. A, B, D, C, B. Excellent. And we have 6, D, B, C, A, D. D, B, C, A, D. D, B, C, A, D. Excellent. Okay, that was quite a pleasure. I hope you enjoyed following along, and stay tuned for more videos. Stop share. Where are we? Stop share and stop.